Hey there. So this is section 1.4 from the in-class practice. It is largely a review of fractions and operations with them. And then at the very end, we'll do a few equations like what we're doing in 1.3, but this time with fractions and the problems. In theory, you know fractions coming into this class. In practice, often people don't remember how to do many of the operations, so this will just be a quick review. For the first one, actually, let me do the directions here first, which is all answers should be given as fractions in lowest terms. And so what I'll see people do is, they get an answer of 1/3 because they put it in a calculator and it says 0.3333 forever, and then they put 0.33 in the computer and it will mark you wrong because that's not actually the same thing as 1/3. So when you get a fractional answer, you always want to enter that as a fraction. You don't want to, like, if let's say we had, let me my pen set up here. Let's say we had 7/3 as an answer. You would want to leave it as an improper fraction. Don't change that to 2 1/3. The computer won't like that. And then also don't turn that into 2.33 because that's rounded and the computer won't like that. So you want to just use the fractional answer as reduced as it can be, and then don't worry if it's improper. So for this first one, we're going to simplify. So that's sort of the idea of reducing these. If you can see the common factor, great, just knock it out of there and be done with it. If you're having a hard time seeing the common factor and how to reduce this, it can help to break things down to primes. So 24, if I break that down to primes, would be 4 times 6. 4 is in prime, so I keep going. That would be 2 times 2. 6 is in prime, so that would be 2 times 3. 36 I would think of as I could do 4 times 9 or 6 times 6. Doesn't matter. Any two numbers that multiply to be 36 works. 4 I can break down to 2 times 2. And 9 I can break down to 3 times 3. So then if I rewrite this fraction as 2 times 2 times 2 times 3 would be the numerator, and the denominator would be 2 times 2 times 3 times 3. I can look for common factors. So I have common 2's, and then I have a common 3 right there. So what would survive is that 2/3. So 24/36 is the same thing as 2/3. If you can spot the 12 right out of the gate, terrific. Think of it as 2 times 12 over 3 times 12, and just knock out the 12s. It may be that you reduce something out of there. Another possible thing you could do is to kind of try something. Maybe you look at that, and let's say you were able to see the 6's. And you went, okay, so 6 goes into 24 4 times, and 6 goes into 36 6 times. That's cool, but you missed a 2, so if you do it that way, just be careful to look at what you have left and go, oh wait, I can still get a 2 out of there, and then that would be 2/3. So this is kind of the long road. You'll absolutely get it right if you factor that down to primes and cross out all the ones that are common, and oftentimes you can just kind of look at it and do it a little bit easier than that. So either any of those versions work, and it kind of depends on how hard the problem is. If it's really hard, big numbers, the going to the primes is actually pretty useful. If it's easier, I often will just look at and simplify in place. So next up is multiply and divide, and these two operations go together in terms of fractions. When you see multiply, the last thing you want to do is multiply. Let's see, what is 7 times 16? I don't know that one off the top of my head. That would be 112. So if I ignore the advice I'm about to give you, we would have 14 over 112. Oops, I just dropped my water, sorry, one sec. And that 112 is kind of a big number to work on, and it was already factored right back here. So when you see multiply, don't multiply. You're just going to make the numbers harder to see what to do with. The way I would look at this one is, first off, the signs. I have a negative times a negative, so that's going to make it a positive. In my numerator, remember we multiply straight across when we're multiplying fractions. I would have 2 times 7, but let's just write that as 2 times 7. In the denominator, I would have 7 times 16, And here's where factoring a little bit can be helpful. That 16, since I see a 2 up there, let me write that as 2 times 8. And then that makes it really easy to see what I can cancel. So I have a pair of 7s in common and a pair of 2s in common. And then that would just reduce. When there's nothing left in either the numerator or denominator, that means there's an invisible 1 there. And so this would be 1/8. Another way to write that, and this is probably closer to what I would do for me, is I would look at this and go, oh, the 7's canceled, right? Those are gone. And I would go 2 goes into 2 once, and 2 goes into 16 8 times. And then there's that 1 is what's left up top, and 8 is what's left down below. It's a little messier, so I try to show it this way just because I think it's easier to follow. But that's essentially what I'm doing. For number 23, this one is a divide. So the thing to think of there is, first off, if we have a whole number like that, we can write that as a fraction by just putting a 1 in the denominator. So let's start there. And then second thing is, if you remember, when you divide with fractions, you take the reciprocal of the second one. So dividing is the same thing as multiplying by its reciprocal. So let's rewrite that as 2 over 1, and then times, we flip the second fraction, 4/5. And if you think of, very briefly, say you have 10 divided by 2, that would be 5, right? If I do 10 times the reciprocal of 2, which would be 1/2, I end up with 10 over 2. It's still 5. So that's why multiplication, you can rewrite it as, division can be rewritten as the reciprocal with multiplication. And then looking here at my fractions, there is nothing common, right? I got a 5 downstairs, 2s and 4s upstairs. So all I can do is just multiply straight across, and that gives us 8/5. That'd be it. Okay, adding and subtracting with fractions is a bit harder. So for subtract, they're going to be the same thing, both for addition and subtraction. We're going to need to find a lowest common denominator. There's a few different ways to do that. This is probably the one, although I don't, like if I'm doing it for me, I wouldn't write out all these steps, but this is kind of showing what I do in my head to figure out what to do. I need to find the smallest number that 4 and 14 both go into, and so I'm going to do a little bit of factoring over here. I'm going to take this 4 and I'm going to think of it as a 2 times a 2, and I'm going to think of this 14 as a 9 over a 2 times a 7. So what I need is for these two denominators to be the same. In order to make that happen, this would need to have a 7 in it because this one has a 7. So this piece needs to be multiplied by 7 over 7. Over here, this has the 2 and the 7, but this one had a pair of 2's. This only has 1 2. And so in that case, I would need to multiply this one by 2 over 2. If we look where that gets us, so 7 times 1 up top would be 7, and then this would be 7 times 4, 28, and then we're subtracting from that, 9 times 2 would be 18, and again 14 times 2, it's the same 28, right, because it's the same numbers down there. And then once we have a common denominator, now we just subtract the top. So 7 minus 18, and that would get us negative 11 over 28. If you can see right off the bat, 4 and 14, what do they both go into? And sometimes the numbers are easy enough to do that. But if you can see that it's 28, then you just think, okay, well, what do I multiply 4 to make it 28? That would be 7 over 7. What do I multiply 14 to make it 28? That would be 2 over 2. And it's a little less writing, a little less fussy, and you get the exact same thing. But this is handy if you have a hard time spotting what the LCD should be. Breaking it down like that can help you see this is a pair of 2's, so this side needs a pair of 2's. This is a 2 and a 7, so this side's going to need that 7. The next one's an addition, so it's the same thing. If you can see from there that the LCD is 63, great, just do that. That's probably a little bit hard for lots of people to see, so let me kind of do it that same way that I just did. And even, I mean, that's actually kind of what I'm doing in my head. I know it's 63, but it's because I went, okay, I have 7 here, 9 that goes in, so 9 times 7 is 63. But this is the step that I'm doing in my head to figure that out. And so if we look at this side, it has a pair of 3's. And so this is going to need one more 3 over here. And that one has that 7, so this is going to need 7 over there. So we got negative 24 over 9 times 7 is 63, plus 5 times 7 will be 35 over 63, and so that's down 11, so that should be 11 63rds. With all these, I didn't say it back here, but 11 and 28 don't have anything in common. 11's prime, so that doesn't reduce. 11 and 63, nothing in common, so I don't have to worry about reducing. If I had gotten, for instance, right here, just pretend for a second I had gotten 12 and 63, so then at that point, that looks like 3 times 4 and 3 times 21, and I would have to be careful to reduce that fraction. But for this particular example, neither of these answers have reduced. Okay, so now we got equations involving fractions. There's a couple of ways to do these. I think I will do the long one first, and then I will show you the shortcut. If I was just thinking of this as, like every other linear equation that we've solved so far, I would do my addition or subtraction first and my multiplication and division second. So I could go 1 minus 1/4 on both sides of this equation. And then that would get me, over here I'll have 1/2 x equals negative 3 minus 1/4. So to subtract these, I would need a common denominator. And in this case, that 3 is a whole number, so I would think of it as over 1. And then I'm just going to slip in there and write 4 over 4, because that will give me a common denominator with this 1/4. So let me rewrite that so it's a little bit easier to see. So now we have 1/2 x equals, that would be negative 12 over 4, and then minus 1 over 4. Come up here with it. So now we're at 1/2 x equals minus 12 minus 1 would be minus 13, and over 4. So now we need to get that 1/2 off of that x. It is multiplying, but it will kind of be a bummer if I divide both sides by 1/2, because then I'm going to have negative 13/4 divided by 1/2, which is doable, but it just makes it look harder than it has to. So instead, let's use our reciprocal. Since this is a 1/2, I'm going to multiply both sides by 2 over 1 to have that reduce out. And that's the same thing as dividing both sides by 1/2. It's just kind of skipping the messy step. So a lot cleaner that way. And now that will give us x equals, I can reduce right here. I have a 2 and a 4, so let's go 2 goes into 2 once, and 2 goes into 4 twice. And so that will leave me negative 13/2. So that was actually the way that I don't like to do this problem. So let me scoot over here, and I'm going to show you a different way to do that that is slightly more confusing but much easier math once you get the hang of it. And this is how I would do this problem every single time for me, mostly because I have the hang of it. It's a lot easier this way. So if I have fractions, as long as I do the same thing to both sides of an equation, I can kind of do whatever I want. And I am not enjoying having fractions, so what I'm going to do is I'm going to clear them. And what I want to do is multiply both sides of the equation by something that's going to make these fractions reduce to whole numbers. So again, for that, we'd want to find the lowest common denominator. And so 2 and 4 both go into 4. So let's multiply both sides by 4. This time I'm going to think of it as 4 over 1 just so I can kind of show how the fractions line up. On this side, I'll just write it as 4 because there's no need for a fraction over there. So let me write this in between step. This would be 4 over 2. I'll simplify in just a second. I just want you to see where all the parts are going. And then this would be plus 4 over 4. And then over here, this would be negative 12. So the beauty of what I just did here, and if once you're more comfortable with this, you can just cancel as you do it. 4 over 2 means this is really 2x. 4 over 4 means that's really 1 and equals negative 12. So once you get the hang of clearing the fractions, then you don't have to do them anymore and you don't have to mess around with all the addition and subtraction. So then we just subtract 1 on both sides. 2x equals negative 13, divide the 2, and there's x equals negative 13 halves. The same as I got over here. So for me, I much prefer this version. This works as if there was like 6 fractions in this. This thing would just kind of be a miserable way to solve it. And this, you just multiply everything by the LCD, clear all the fractions in the very first step. So that's my preferred version. And so for this one, I will show my preferred version. So over here, it looks like we have, I'm actually going to rewrite that down here. Looks like we have 5s and 10s, and so our LCD is going to be 10. So we're going to multiply everything by 10. Scroll up. So there I would have 10 over 5, so 5 goes into 10 2 times, so 2x. Careful not to miss the x, even though it's not a fraction, it still has to be multiplied because we're multiplying everything. So that would be plus 10x, and over there the 10's just cancel, and we got 7. 2 and 10 would give us 12x equals 7, and divide the 12 over, and x equals 7/12. So to me that's a lot easier than getting 5 over 5 here, and then actually when you bring that over, so then you'd have 5 over 5, so that'd be 6 over 5, and then you'd be having to multiply fractions over here and reduce. So if you can get your head around that clearing step, it gets you a much easier problem to do than if you did it the other way. And then lastly, I'll just point out 7/12, nothing in common, and so no need to reduce that answer.